I am Dr. Ashok. I am from EC department. Today I am going to lecture about microprocessors and micro subjects subject. In this subject, I am going to discuss about interrupts of microcontrollers. In this microcontroller having five types. 8051 real-time control by five interrupts. In this five interrupts having INT 0 bar, INT 1 bar, TF 0, TF 1 bar, and serial communication receiver and transmitter, which represented by RI and TI. These are five interrupts. In that five interrupts, three are software interrupts and two are hardware interrupts. INT 0 bar and INT 1 bar, these two interrupts are hardware interrupts. And remaining three, TF0 and TF1, TI or RI. These three are software interrupts. Today I am going to discuss what is interrupt first, how give priorities, where it will be occurred during main program. Interrupt is nothing but breaking the sequence operation in main program. Each interrupt having vector address. So TF0, TF1, these are two timer overflow interrupts, TF0 and TF1. Serial communication internal interrupt having common for TI or RI. TI is related to transmission, RI related reception in the serial communication. And other two are two hardware interrupts, INT 0 bar and INT 1 bar. During main program execution time occur these five types of interrupts. So these are how giving these priorities. So here priority and vector address of interrupts in 8051, we know INT 0 bar and INT 1 bar, these are two hardware interrupts, and TF0, TF1, RI or TI. In this, these three are software interrupts, right? So how give priorities? When T0, T1, these are two timers. So clock is give internally by 8051. Then it working as timers. If these same timers T0 and T1, these two timers take clock from external sources, when it working as counter. These two differences between timers and counters. So during this execution main program on time getting these five interrupts, how give priorities? First priority is INT 0 bar, first priority. For vector address of ISR is represented by interrupt routine subroutine. So INT 0 bar address is 0003H. Here H represents hexadecimal notation, which having 16-bit address. Each bit represented by 4 binary digits. So here vector address is 000 3H. And similar manner, second priority is TF0, which is software interrupt, which is second priority, and vector address is given 000BH. And similar manner, third priority is INT 1 bar. This is for third priority. Vector address is 0013H. And fourth priority TF1. Which priority is fourth priority? Vector address is 001BH. And last priority, fifth priority, either TI or RI. It is also a software interrupt, and which is last priority, fifth priority of vector address is 0023H. Here H is represented is hexadecimal notation of these bits. For example, 0003H of priority 1 of interrupt 0 vector address. So here these 16-bit address, first 0 represents in binary notation 0000, and second 0 represents 0000, and third represents 0000, and fourth bit is 3. Hexadecimal notation is 0011. So these are 16-bit address, 0 to last 11. Up to these are 16 bits of hexadecimal notation. For example, this 0 is representation, 0H represents with 4 BH, 0000B. Here B represents binary notation, H represents hexadecimal notation. Similar manner, vector address in the hexadecimal notation 0003H. So these are 4 bits in hexadecimal notation. In this hexadecimal notation, in terms of binary notation, we can get a 16 bits, 0000, and other 0 represents 0000, and other represents 00000, and last 3 is there in hexadecimal. So it represents 0011B. Here B is binary notation. So these 16-bit address is vector address. So these vector address, when during execution main program, when occurred INT 0 bar interrupt, then these main program stop that and going to there in ISR address, vector address 0003H, where subprogram is execute, then come back into main program, then continue the process. This is occurred and process by the 8051 microcontroller. So here these related about software interrupt and hardware interrupt. When during main program execution, possibility case of these interrupts, then when if for example we can get at a time many interrupts are there, on time we can take priority wise to control the main program. So here these all interrupts are controlled by IE register and IP register. IE is interrupt enabled register. These contain 8 bits, bit addressable. Each bit IE 0 to IE 7 bit addressable. First, from take right side onwards, these are EX0, ET0, EX1 and ET1, ES and ET2 and EA. These all are 8 bits. These all are 8 bits, which bit addressable. First right side bit represents IE0, second bit represents IE1, third one IE2, IE3, IE4, IE5, IE6, IE7. These are bit addressable. So IE1 represents EX0. EX0 is enable INT 0 bar. Second bit ET0. ET0 represents enable timer 0. And EX1 represents enable INT 1 bar. And next ET1 enable timer 1. Next ES enable serial. ET2 it will be reserved for any program. And EA enable all. How these interrupt enable register is active? When enable this make to enable IE register, then it will be make it as 1. Then all bits are enable 1. If to disable it, make it 0 of EA. When EA equal to 0, total all bits are disabled. When EA equal to 1, then make it into all bits are enable. Means give 1, right? Next, IP register. IP is interrupt priority register, which is also a bit addressable, which it also a 8-bit address. So then it will be give as PX0, PT0, PX1, PT1, PS, PT2. These also individually bits addressable. First bit IP0, IP1 and IP PX1, PT1, PS, PT2. These bits are same. How give priority? Which main agenda is PT2 is reserved here in any program. PS represents priority serial. Already we know priority serial. First priority, second priority, third priority, fourth priority, fifth priority. Just before we discussed about these, how give priority. Then PX1. PX1 represents here priority INT 1 bar. PT0 priority in timer 0 and PX1 priority INT 0 bar. So here when priorities we know, first priority is INT 0 bar we know, second priority TF0, third priority INT 1 bar, next fourth priority TF1, fifth priority TI or RI. So in the duration, if give occur any interrupt, then give first priority is INT 0 bar. If make it into I want to give priority in TF1, then make it into the TF1 give a first priority, which depends on user programmer. So you can give TF1 is first priority, then go to as usual original order. Means here first priority I want to give here TF1 is first priority, here first priority. Then automatically go follows to second is either TI or RI and go to your INT 0 bar is third priority and fourth priority TF0 and fifth priority INT 1 bar. So here if for example here given TF1 I given into priority, first priority. If I want to give two first priorities are there, give for example I want to here TF1 is 1 and INT 1 bar is first priority. You can check once, you can observe here I want to give first priority in INT 1 bar and second also here give TF1 second. Make it into these two are priorities by user or programmer. So how give next priorities? You can take your original priority. Here originally you can go order by serial RI or TI. Here third priority. Next go to fourth priority INT 0 bar and TF 0 fifth priority. These are priority wise according to user or according to get in the main program. Can consider it with according to vector address, go to sub instructions and come back into the main program. This is execution process. So next I want to go explain timers and counters of 8051 microcontroller. How these we know when it working as timer, when working as counter. When internal clocks given to the timers, when it working as timer, that we know. And counter, when clocks are getting from other sources by external, then it called as a counter. So these 8051 has two 16-bit timers, T0 and T1. It takes clocks by internal or external. Internal giving clocks 8051, external clocks taken from other sources by external. So here two bits timers T1 and T0. Two timers are 16 bits working as up counters. These two timers are working as up counters. T0 and T1 is further divided into 8 bits of registers TH0 and TL0, and T1 is divided into TH1 and TL1. Here T0 we can now discuss about only T0. After go for T1. For example, here T0 contains 16 bits, TH0 8 bits, TL0 8 bits, here 8 bits, and TH0 also 8 bits. So these first 8 bits LSB, first 8 bits is lower bits, and H represents here higher bits. So here first TL lower bits, H higher bits. Here both are combination of TH0 and TL0 is timer 0 of 16 bits. So here how to load these counts of 16 bits with TL0 and TH0. TH0 also a 8-bit register, TL0 also a 8-bit register, T0 have 16-bit register. So here TH0 and TL0, how these load bits in the timer 0. Only I am discussing about only T0. As similar manner go with timer 1. So here these timer T0 timer working as up counter. When give clock, it will be increment by 1. When already I given here T0 is contain 16 bit. When this 16 bit give 1 clock, it will be increment by 1. Means here 0 0 0 0, here 16 bits, right, 16 bits. So here when get 1 clock, then it will be increment by 1, 0 0 0 0 1. Then it is also 16 bits. Then after get other clock also, then it will be 0 0 0 0 1 0 1 0 1 0. So again get a 1 clock. So after last up to count all 1 1 1 1 1 16 bits. I am telling only in binary notation. In the hexadecimal notation, all ones 4 bits contain F in the hexadecimal, other 4 F, other 4 bits F, other 4 bits F. These 4 bits F, H count is completed. Then come back into count when clock is continuous process. Clock is getting continuous process. When complete up count up to F, H, again count roll back into 0, 0, 0, H. F, when F, H2 get back into 0, 0, 0, 0, H. When get occur, interrupt timer 0. Here we are talking about timer 0, overflow, interrupt, which represented by TF0. TF0 is timer 0, overflow, interrupt. So when roll back H2 0, 0, 0, H on time get a F0 TF0 interrupt. We know TF0 vector address is there. TF0 vector address is 0, 0, 0, 0, BH. It is represented with ISR, interrupt subroutine addresses. So when during main program, here you can observe previous slide, program is main program. It will be during execution, we can get a interrupt of TF0. When go back to ISR address, interrupt subroutine program, which already predefined subprograms, then it will address is our what address? TF0 address 00003H. Can go to this address and continue to execute this subprogram, sub-instruction. Then go back to the main program with RETI instruction and get continue to that main program. As similar manner, when in timer 0 got interrupt TF0, when go back to vector address 0, 0, 0, BH, then complete that subprogram execution, then go back into main program, then continue that execution up to till end of main program. This is contain how program continuing. Similar manner here in the timer 1. So here when it reaches to FH, it will be rolled back to 00H, and during that will generate timer overflow interrupt. At that time count formula is count equal to FH minus value plus 1. Why here given plus 1? When occurring interrupts purpose, we can add here plus 1. Value is 1. One example you can check it here. I want to 9 is value. 9 is value. Then count is equal to we formula FH minus 9, value is 9 plus 1. We can get is F7. So how is here? Already here all H minus in the hexadecimal notation we can reduce value H, the decimal notation reduce value. 9 plus 1 means minus 8, H hexadecimal notation. F represents, we know, 15 minus 8, 15 minus 8, 7, F. These are we can value of count. In this how is representation in the timer 0, which is TL0, which is TH0. TL0 is what my lower bits of TL0. higher bits TH0. I am talking only about timer 0 interrupts, and count we can got count is equal to here F7. How is getting? We required value is 9 plus 1 is added here for roll back into get interrupt in T0 timer 0. So here how is load this TL0 and TH0? How is here instruction use here in the timer duration timers move instruction used here move TH0 comma hash FFH H0 TH0 we know FF, and similar load this FF value is loaded into TH0. Similar manner you move TL0 comma hash F7H. This F7 is lower bits which is loaded into TL0. We know L is represent lower bits and H is represents higher bits. So here count is when given clock, every clock it will be working as up counter. When first clock is 00 16 bits H, already we know explained about first clock 0001 last 16 bits, and second clock 0000 last 10, and like that clock is counting when all ones get back into after 00 when occur every clock is moving into this count is here. Same timer or counter, already we know if clock is count given by internal clock of 8051 then it will be timer. If clock is given by external on T0 and T1 it will be counter. So here two configures are there, T mode register of 8051 and here it will be decide timer or counter configuration of 8051. Here also if how we load this instruction of TL0 and TH0, here I am talking about only T0 only. T1, about T1 you can analyze. T0, when it will be T0, it count will be increasing after every clock. When count rolls from FFH to 00H, it will be make TF0 interrupt and to 1, then it will be go to ISR address. ISR address is 0000001 BH 00BH. It will be execute continue to subprogram, then go back into the main program. Again count start from 0000H to again counting when clock is going internally, then it will be count again one by one. Both the timer 0 and timer 1 working as up counters. So this is also about timers and counters. How it working? Timers and counters in 8051 microcontroller. These here accelerator frequency and frequency accelerator by 12. In this here this upper block is related with the software interrupt, and below T0 or T1 it is also by hardware interrupt. Why I am telling software and hardware? When timer related TF0 and TF1 and TI or RI, these are software interrupts. During getting interrupts, timer interrupts are TF0 on TF1. Here counter, when counter occur, counter interrupts are INT 0 bar and INT 1 bar. These two interrupts are hardware interrupts. So when working as here counter, here working as timer, which depends on CT bar, C by T bar. C by T bar equal to 0. This C by T bar having in the T mode register. Having here 8 bits M0, M1, C by T bar and gate, and M0, M1, CT bar and gate 1. Gate is represent external hardware, and here of timer 1, this gate is of timer 1, this gate is of timer 0, and M0, M1 of timer 0, and this M0, M1 are of timer 1, and CT bar is of timer 1, this CT bar of timer 1. These 8 bits of time mode registers. In this M0, M1, these are which mode is working. These two modes are, these two bits are 0-0 combination, 0-1 combination, 1-0 combination, 1-1 combination. When it having 0-0, which is timer 0, mode 0. I am telling only timer 0, and 0-0 case timer 0, mode 0, and 0-1 case mode 1 of timer 0, and 1-0 case mode 1 of timer 0 case, and 1-1 case mode 3 of timer 0. These are modes. And CT bar, when CT bar equal to 0, which working as timer, when CT bar equal to 1, when it working as counter. So CT bar is main role of timer 0, timer or counter. When CT bar equal to 1, it will be working as timer counter. When CT bar equal to 0, when working as timer. So after that, during these 2 points are connected into one line, and here one switch is there. Switch is, when switch is close, means here output is 1 of this combinational circuit. This is a combinational circuit of this AND gate output equal to 1, then this switch will be closed. When it will be 1, it will be not counting. When start count, the switch is close. When close, this AND gate output equal to 1. Which cases this TR or T1 is must 1. Other input also 1. Other input also a 1. Which case AND gate output equal to 1. Other cases 0. Then here not counting. Must TR, either TR0 or TR1 must be 1. If you get second input also a 1, then here means what? OR gate output equal to 1. Before that OR gate equal to, when here OR gate output is 1, before it will be INT X. Here X means what? Either 0 or 1. INT 0 bar 1, INT 0 1 bar here. So here 1 bar is missing. So here must, here required, here 1 case, here will be 0. In possibility case here 1, and other case here 0 and here 1. Here possibility case 1. During these cases you can get a must and get output equal to 1, then it will be switch is close, then count will be started. It is main working of timer and counter in 8051 microcontroller with CT bar 0 or 1. So here modes of timers, counters in 8051. Here mode 0, timer mode 0, which case 00 case, 00 case. And here timer mode 1, 01 case. And timer mode 2, 10 case. And mode 3, timer mode 3, 11 case. In timer 0 contains 13 bits timer or counter. Here timer mode 1, 16 bits. Same similar manner here mode 2, 8 bits. And timer mode 3, 8 bits. So here all are blocks. TL, the L represents here lower bits, H represents higher bits, TF represents what? Interrupt occurred, either 0 or 1. X represents in this block, X represents either 0 or 1. During I am talking only about timer 0. When timer 0, first L bit, lower bits having 5 bits, higher bits having 8 bits, total 13 bits. So 2 power of 13 equal to maximum count up to 8k. Means after these 13 bits also a possibility case from 0, 0, 0, 0, 13 bits last 0, and last possibility case 1, 1, 1, 1, 1, 13 bits only in binary notation, 13 bits, and then all count is completed, then again go to 0, 0, 0, 13 bits. When all ones to zeros, all zeros, when get back into roll back to 0, 0, 0 H, when occur TF0 here, TF0. So here TF0 occur. Same similar manner in the 16 bits. Here not possible in hexadecimal notation. So I am told in binary notation only. Here same, here timer mode 16 bits. Here L contains lower bits contain 8 bits, higher contains 8 bits. So in this total 16 bits, 2 power of 16 bits possibility 64k. Count maximum count up to 64k. So maximum delay also here 65536. When 2 power of 16 value is 65536. Here also 2 power of 8 equal to exact 8192. So here mode 2 also, here some different you can observe. 8 bits auto reload TL from TH. TL, here TL first up block is TL, lower block is TH. These are when only you can observe only here 8 bits count. Here in the hexadecimal only 2 digits, FF to 00. First count starting from 00H in the hexadecimal notation, and up to count maximum FFH. Then again go back count, roll back into 00H. Occur TF0 in the 2 digits only, because of here 8 bits are there. So when occur TF0, it will be into here in this box, and same signal get back into that here this shape, diamond shape. So when here occur TF0 interrupter, Then auto reload into this TFX value is reload into that here TLX. So again these same THX also a count will be started. Again same get back into TF0 of THX here before TLX TF0. So this similar explanation into that mode 3. Mode 3 here TL0 TF0 TH0 TF0. Here compare with observe these first mode 0 and mode 1 you can individually getting interrupt here TF0 and TF1. Here TL0 contain 8 bits, TH0 contains 8 bits. Here in the hexadecimal notation having 2 bits. Here 0 count 0 0 H2 F F F H F F H. Then get TF0 individually. Again TH0 also a 8 bits in hexadecimal notation. Count 0 0 H2 F F H and same T F1 occur of higher byte. So when count FF2 again count to 0 0 H roll back to 0 0 H, then get a occur interrupt of timer 0 TF1. So these all are about how working timers, counters, and how is further divided into two registers T0 of TH0 and TL0, and how is these registers T mode registers in the which mode is working M0 M1, and pins CT bar is main role of count start, and timer vector addresses, and these are how is priorities, how is T0 and T1 block working of by 8051 internal clock and external clock. So finally this how is timer programming in 8051 microcontroller. One program generate delay of 20 microsecond and send logic 1 on P2.0, assume accelerator frequency equal to 12 megahertz. So here I am talking only timer 0 only. Timer 0 only. You can analyze timer 1. So here timer 0 mode 1 is as possible as in many microprocessors, microcontrollers. So working with only mode 1 only. In the mode 1, M0, M1 is what 0 1 case. Mode 1 having M0, M1 is 0 1 case. In the T mode, here M1 and M0, 1 0 1 case, mode 1. So here you can write it here. Same, all bits are 0. In the you can check it in the T mode register. T mode equal to this is 0 0 0 0 0 0 0. Here which mode? 0 1 case mode. The 0 1 is having mode 1. So you can write it 0 0 0 0 last 0 1. B represents here binary notation. To start timer 0 with mode 1, Tcon is here, fourth bit is here, what TR0. TR0 represents always time control. Starting time means count start here. TR represents count start. So here when clocks is coming to the count block when start the count. So here TR equal to 1, TR equal to 1 here, TR0 equal to 1. You can give here fourth bit is 1 here, remaining all are zeros. When means what? Time start. To stop the time, then it will be 0. Here also fourth bit, here 0. Here when, here 1 start time, here stop time. So to calculate count, one count time 12 by oscillator frequency. Oscillator frequency given here in the problem, 12 megahertz. So here what? 12 by oscillator frequency 1 microsecond. To value of count 20, already here given 20 microsecond, here given here 20, in the convert into the hexadecimal notation 14H. This 14H is that hexadecimal notation. This up count value, this is the count value. So we know formula, count equal to F minus count value. Count value is 14 hexadecimal notation plus 1 here. Plus 1 is when for occur interrupt purpose we can add here plus 1. So when what equivalent value is ECH. So in that EC is lower bits, FF is higher bits. TL, I am talking only about timer 0. In that TH0 and TL0. TH0 is what? Higher value here in this FF ECH. These are higher. TH0, this is for TL0, lower bits. These are loading. How is loading? We can program, we know. Here move, how is instructions, how is write program, you can observe once. Move T mode comma hash, this value written here 000000001 B notation, and timer 0 mode 1 meaning, and move TL0 comma hash ECH or ECH, we know ECH, and move TH0 comma hash FFH, here TH0, here we know TH0, and next instruction is move TCON comma hash when count start timer. So here given 1, TR0 equal to 1. When if you stop, then stop here, instruction given 0. TF fourth bit is TR0 equal to 0 return. So here wait 20 microsecond according to here our given problem, 20 microsecond. When roll back to 000 H like. So here the stop timer, and these are end the program. This is for one example timer programming in 8051 microcontroller. Thank you for giving this opportunity to take microprocessor subject in the topic of timers and counters, and I am discussed about all these definition of interrupt, types of interrupts, timers and counters of my 8051 microcontroller, how is these working timers and counters, and one example given timer programming. Thank you.